Okay, for Sec 4 and 5 students, so do take note that this last part of the chapter actually compares alkanes and alkenes. Okay, so we have learned a lot about alkanes and alkenes, so this part we really need to know how to compare them. Okay, so we're going to compare based on using two methods, considering the similarities and also the differences. Okay, so that's the main, it's like a compare and contrast method. Okay, so for similarities, you realize that for alkanes and alkenes, they are actually hydrocarbons. Okay, we learned in the earlier chapter. Hydrocarbon simply means that it's made up of two words, hydro and carbons. Okay, so it simply means a compound that contains hydrogen and carbon atoms only. So for both alkanes and alkenes, they do have only carbon and hydrogen. For example, for alkanes, it's CnH2n plus 2, whereas for alkene, is CnH2n. You'll notice that they only have carbon and hydrogen. Okay, number two is actually one of the chemical properties. You realize that for alkanes and alkenes, they are very, very, very flammable, so they burn very easily. Okay, and one of the reaction that they all undergo is combustion. So they both undergo complete combustion and incomplete combustion. For complete combustion, they produce CO2 and water, carbon dioxide gas and water. Whereas for incomplete combustion, they produce a mixture of soot, carbon monoxide, and carbon dioxide. That is for incomplete combustion. Okay, so you can refer to the earlier parts about chemical properties to know the difference. Okay, now for differences, so we compare alkanes and alkenes in terms of the differences. So one important part is the functional group. So the first part in terms of the structure is actually the functional group. You will notice that for alkane, the functional group is it contains only single bonds between carbon atoms. Very important, is between carbon atoms. That means most of them only exist as C, single bonds. Whereas for alkene, you will definitely see one C double bond. Take note, only one. So I don't want you to draw the entire structure with all double bonds. Okay, reactivity. Because alkane is what we learned as saturated, and alkene is what I learned as unsaturated. An easier word to differentiate saturated and unsaturated is the word crowding. Okay, saturated is like very, very crowded. Because they are very crowded, they are generally unreactive. They don't want to react with anyone else. Whereas unsaturated, they are not crowded. They have a lot of space, so they can add people in easily. Okay, so that's why they are generally very reactive. This analogy of crowded also lead to the type of reaction that they undergo. Because alkane is saturated, they are very crowded. It is like a room filled with 1,000 people. So if I have a student standing outside the room wanting to come in, the only way is to substitute. That's why alkane generally undergoes substitution reaction. Whereas for alkene, they are generally not crowded, so there's a lot of space left. They will just undergo addition. You can easily add people into the room because the room is not crowded. Okay, so that is an analogy. Now, how do I tell alkenes and alkenes apart? So generally they are colorless. So I have two solutions and both are colorless. How do I tell which one is alkane and which one is alkene? That is where one of the reaction that we learn is very important, which is bromination. Okay, bromination generally means adding aqueous bromine. And aqueous bromine, if you remember the color from the chapter of periodic table, is actually reddish brown. So for alkane, which is a saturated compound, it doesn't want to bond with bromine. Okay, so it does not react at all unless you give him or her, you give alkane UV light. If not, it doesn't react. So because of that, the reddish brown remains reddish brown. There's no change in color. Whereas for alkene, it rapidly decolorizes because a reaction has taken place. Therefore, it has turned it colorless. So I just want you to refer to the previous page where this is the part where you can see in terms of the color difference very clearly. For alkanes, it remains reddish brown. Okay, for alkanes, it remains reddish brown. Whereas for alkene, you can see that it turns colorless. So it's another word is called decolorizes. So this is one identification test to tell the difference between alkanes and alkenes. Okay, then flammability. Okay, this is just for you to know alkene is smokier. So when I burn it, it is actually more smoky. There's a lot more black color kind of flame as compared to alkane, even though they may have the same number of carbon. For example, ethane and ethene. One is C2H6, one is C2H4. They have the same number of carbon, but for alkene, this one, it burns with a more smoky flame. Okay, so that's the main difference between alkenes and alkenes. One real world example, or one what I call natural alkenes and alkenes that you really need to know, will be the difference between fats and oils. Okay, so you learn this in FCE or FNN students if you are familiar. There are many different types of fats. Okay, just the word poly unsaturated, you need to know the meaning. Okay, poly is like polyclinic, there are many doctors. Polytechnic, there's many courses. So poly simply means many. And unsaturated, which is covered earlier, it simply means the presence of CC double bond. So the definition of polyunsaturated means it means that the compound has many carbon-carbon double bonds. Okay, this process should be familiar to you because it changes from an alkene to an alkane. Okay, so this process is known as hydrogenation. You learn it in the previous part under addition reaction of alkenes. You also know that there's a condition required, which is 200 degrees Celsius, nickel catalyst. So this actually, the real world example will be it converts vegetable oil to margarine. And if you see this table where it refers to the different types of fats, you realize that polyunsaturated, which is vegetable oil, is actually lower risk of heart disease as compared to margarine, which has increased risk of heart disease. Okay, so this polyunsaturated vegetable oil is actually alkene, and margarine is actually alkane. So you do need to know how it's linked to your real world or real life applications. Okay, so with that, we finish this chapter on alkenes. Go read your notes, underline all the important keywords, and know the difference between alkenes and alkenes. Okay, thank you.